Echo. Objective: to learn the phenomenon of echo. Sound is propagated through a medium by a back and forth vibration of particles. Sound waves will travel in the same direction as that of air particles. For this reason, they are known as longitudinal waves. Like light waves, sound waves are also reflected, according to the law of reflection, which tells us that the angle of incidence is equal to the angle of reflection. Sound will be reflected off a smooth surface. Sound travels at about 340 meters per second. It will take only about 0.1 second to travel 17 meters and reflect back. We can perceive the sound for only 0.1 second. And if the sound reaches our ears after 0.1 second, there will be a discernible delay between the original and the reflected sound. The reflection of sound waves off a surface and back to the listener is its echo. Outdoors, particularly in valleys, sound waves will reflect off distant surfaces before reaching a listener's ears, meaning they will take a longer time to reach the listener. If a sound is reflected from the walls, ceiling and floor of a room, it will be jumbled because of multiple reflections. This phenomenon is known as reverberation. Using echoes, we can calculate the distance between the source and the reflection surface with the equation S is equal to V multiplied by T whole divided by 2, where S is the distance between the source and obstacle, V is the velocity of sound medium, and T is the time interval between direct and reflected sound. The principle of an echo is used in sonar, sound navigation ranging, a device used for locating submerged objects and submarine communication by means of sound waves. Bats also apply echolocation technique to navigate in the dark. Summary: sound travels in the form of longitudinal waves. The reflection of sound waves from a surface and back to the listener is known as an echo. Echoes are distinct when the reflective surface is beyond 17 meters. Sonar and the echolocation of bats are applications of echoes.